Hello, everyone. Good day once again. Today is another day for us to continue what we've started. Okay. I know we are on set, and we've been able to, you know, talk about a lot under sets. Okay. So today we will continue. But before then, we need to go back, to the previous lessons. But um, we've changed the platform, so if you want to go back, just go and watch what we did the previous, and then join this one, all right, so that you won't be confused. Today we are to look at types of sets as we talk about the other time. And then before we go there, we gave an exercise to do, all right. This time when we give you exercise, all right, we'll be expecting you to do it, capture it, take a picture of it, and send it to us, all right, on our WhatsApp platform or our Telegram, or you can mail us, all right. If you don't have email address, you can just write your telephone number and you add at gmail.com or at yahoo.com and send us, all right. um yes, and send us, okay? Or you can use your mom's email address and send us. Or you can create one. Just go and follow ICT classes and then know how to create email. All right. So that one we have done it for you for the new starters, so that you can create email address. Very simple. All right. And cheap. Okay. So today we are going to look at our homework. But before then, as you know, as usual, we will always, remember you about what you should do. We are not charging you. We don't put any charges on what you're doing, okay? But from your heart, you donate to support us. Show appreciation by, sending us donation on 0245 21 52 66, 027 888 7080. And also remember, um, remember that we have a lot of classes going on. We have elective math class going on. We are looking for a cons teacher to tackle on economics for you. And then we have JHS also as well. So if you have, if you have a friend, if you have a brother who is in SHS, JHS, a sister, just introduce ftpclasses.com for the person to follow us. And also we do tree as well. Tree akenkan natural. It's very nice to know how to read tree, because that is your mother language, okay? Brofono. Yeah. Brofi to me kind of papa be the brumusa, you know that. Alright. So let's tackle our homework. Um let's read it. It says that use set builder notation to describe the following: the set of odd numbers greater than 30. That's the A part. We have the set of prime numbers greater than 2 but less than 24. We have C, the set of triangles. We have D, the set of positive integers less than 100, the set of rivers in Ghana. Okay. Alright, so we are using set builder notation to describe the following. Okay, we are not listing them. And remember that we were able to know what a prime number is, what multiple, what means prime factor. We've done a lot. All right, so If you're new here, just join the old videos and follow us. Okay. All right. Just take your time, go through one, then now. And remember that when we are done with set, we are going to tackle past questions under set. Past questions under set from A to Z. So if you are in your WASI room and there's a question to set, don't panic. Alright, you can do it, you can make it. Don't say Samidi mini mathematics. Nobody knows it. Okay, we are all helping each other. As I learned from you, you too, you learned from me. Okay, alright, so don't panic about that. Cry. Okay, so here we go. We are using set builder notation to do this, and then let's continue. Alright, okay, so here we go. Okay, so let's write solutions. Alright, let's write solutions. Let me give space, say solution. Alright, so A, what do we have for the A? It says that the set, use the set builder notation to describe the following. So the set of odd numbers greater than 30. So how do we write it? So it says that let X be the members of of the set, right? Okay, so let's write something. Let X be the members of the set. Alright, so as X being the members of the set, how do we write it? Alright, so here we go. There we come and says that, if you want to write a set, you know what it means. We open braces and we close the braces. Alright, I know you remember all these things. So we bring because we are writing sets, so we bring our braces. Okay, let me do this. Alright, I close it. Alright, so it says that X, which is the members, X is that. X is what? What is X? X is odd numbers, right? Odd numbers greater than 30. Alright, so X is what? Is an odd number. X is an odd number, and X is what? And X is what is greater than 30. Very simple, very cheap, very easy. Alright, simple, cheap, and easy. So we've done it. Did you get it correct? Look at it. Yeah, I hope you get it. Yes, I know you get them. Alright, so let's go to B. Okay, X is said that, which X is the member, so X as a member is said that all the members of X, all the members of the set, alright, all the members of the set is an odd number, and X is greater than 30. Alright, so do the B aspect and let's see. B, I know you can do the B right now. Do it. So let's read the B and let's see. As you're doing the B, remember to donate to support us. Okay, you can. Thank you very much. Alright, so let's do the B. I know you've done it, right? So let's do the B. um, the set of prime numbers greater than 2 but less than 24. So this one is giving in a range, right? So how do we do it? So like we always say, we let the x be the members, x being the members of the sets. Alright, so how do we do it? We are writing sets, so we bring our braces. Then here we go. Please, I'm using computer, that's why I break the braces before I write inside, so don't let me confuse you. Okay, let me do it this way. Don't go and write your braces and try to write inside, because if you do that it will expand. Right, that's why I'm using a computer to do that. That's why I bring them before I put it. All right, but let me do it this way so that it will be very easy. All right, okay, so we say that x is said that x is what? X is a prime, number. Okay, x is a prime number, so x is a prime number, which x the x, they are prime numbers. All right, so we said a member, which is x represents all the members. Okay, so a members in the set is a prime number, so you just write member, a prime number. It's a prime number. Then it gives us a range. So what is the range? It has given us a range. So what is the range? And what 2? It says that it's greater than 2 but less than 10. Alright, so it means that 2 is less than x, right? 2 is less than x, is greater than 2, therefore 2 is less than x. Or we can say that, I hope it's clear. So 2 is less than x, which is the member. 2 is less than x, which is the member. And also x is less than, and also x is less than 24. I hope you're following. Very cheap, very easy and cheap. Alright, and panic it. X ni the x na general my members in the set, okay, or the elements in the set. And you say x no, which is the members, no, one member be so still like x na a prime number. And then the range of the mind is the set of prime numbers greater than 2 but less than 24. So x be a prime number, and what is it that 2 are less than members, x, and so it's less than 24 because x greater than 2. Okay, all right, so don't be confused. Proper way of writing this. All right, so let's go to the C. What is the C? What is the C saying? C is saying that let's make a space. Let's make C. C is what? It's a set of triangles. So members, as we are writing sets, what do? We bring braces, and we say that x, as we always do, x. Let us make x. Okay, let me write it. All right, let me write it so that there won't be any confusion. let X also be the same thing, right? Members of the set. Members of this set, which we say that we bring our braces. That shows that we are writing the set, right? So it says that X is said that okay, X is what? X is what? X is a triangle. It's a triangle. Okay. I hope it's clear. Alright, so okay, let me finish and then let me ask this question. Let's go to the D aspect. The D is what? D reads like the set of positive integers less than 100. Set of positive integers less than 100. So we make X be the members. So let X, alright, X be the members of the set. Alright, so how do we write it? We bring our curly braces, we bring our braces. Then we say that X is said that X is what? X is a positive integer. It says positive integers less than 100. So X is a positive integer. I hope it's clear. And what is it? It gives us range. So X is less than 100. Okay? So if X is less than 100, which the members are less than 100. So while but the members are less than 100, and we know that X is a member. We've used X to represent the member or the members. So it says that X is less than 100. X is less than 100. We close our braces. Very simple and cheap. Alright? Okay. So the E, do it yourself. Okay? It is said that it is a river in Ghana. That's it. Do it yourself. Alright? So we can say is 1 to 5, right? How many did you get? Alright, so if you were able to get 3 correct, then it means you are following. You do understand them. Alright, if you get 4 correct, bingo. 5 correct, all the 5, then you are bingo. If you get 2 correct, it means that you are progressing. Alright, so I will advise you to go and watch the previous videos, tackle the same questions, and make sure that you get at least 3, 4, 5 correct before you move on, before you follow. You get it, so that you understand it, because it means that your understanding is coming. Alright, it means that you are getting it. Okay, so that's what I advise you. Don't rush. This is a part-time teaching for free. All right, we are not charging you that you're supposed to rush to follow. No, but rather we appreciate your donation. All right, so donate 0245 and if you are in SHS and you have products to obetumi de abra na ya market amount and obetumi are joining the ICT also, so that after school you know how to use your computer, you know how to type, you know how to do everything. Okay, all right, so we keep moving. Right, so today we are looking at types of sets. All right, so let's go. Let's see today's lesson. Today we are going to look at types of sets. Okay, is it what we are doing? We are helping you, preparing you for your exams, so that when you go and then you write your exams, you're going to get, at least B. If you are not good at all, you should get B. All right, so after this course, after this class, after this topic, we will be solving past questions. Please take notes. We will be solving past questions. So let's go to types of sets. Let's go to types of sets. So let's write a topic. Type of types of sets. All right, so we are writing something down. Okay, we are writing something down, then we solve questions under them. Then we will come to past questions. We will solve all the past questions. We will host on live coverage. Then we talk about our difficulties in set. Then we end set. All right, then we will move on to different topic. And if you want us to treat a different topic, just send us. All right, send it to us, and then because it's our extra classes, it's extra classes that we are doing. So even if you are in SHS 1 and someone is in SHS 3, it's extra classes. So you need to just follow, be ahead of your colleagues, and then prepare yourself. Okay, so here we go. Types of sets. Let me detect it so that it will be very fast. All right, because I don't want to type, I want to detect it. All right, so let's detect it and let's see what we have. So we are looking at type of sets. Okay, so let's detect it. Okay, we are going to do detection. All right, so write something down. 1. Finite set. A set whose last member can be found is a finite set. For example, comma, the set A equals braces 1, 2, 3, 4. For example, let's bring example. Okay, so it says that finite sets is a set. All right, not I said, sorry, I'm detecting. So finite set is a set whose last member can be found. Alright, so finite set is a set whose last member can be found. Alright, so any set whose last member can be found is a subset. It's a finite set. I hope it's clear. So let's look at the example of finite sets. So for example, we have a set of A equals set A. So how do we write sets? We bring our braces, right? So we say it's 1, 2, 3, 4, 5. Okay, let's close it. All right, so we can say that this last member can be found, right? And its last member, the member is not this number, its last member. Okay, so when we count it, we can say is 1, 2, 3, 4, 5. All right, so if we see, a set like this, its last member can be found, then it's a finite set. All right, so let's write something down. Example 2, B. Okay, let's make B set B. All right, a set B. Let's write this. Set B, we say this 1, 3, 4, 5. All right. Okay, so let's make this 5 here. 5, then we make 7. Okay. All right, so let's write something down. So set B is also a finite set with 4 members. Full stop. Note that the objects of a finite set can be counted. Full stop. So what you got to know is that you see, with this one, let's look at something here. With this one, we have 5 members, not a number, not the last number, but rather its member, right? So the last member. So 1, 2, 3, 4, 5. So it has 5 members. And this one too is 1, 2, 3, 4. Okay, we didn't write that 7. No, it's not that the number, but the number of members can be found. So we say that we have 4, 1, 2, 3, 4. So set B is also a finite set with 4 members. All right, so we make notes. Sorry, I think my machine is the one that is doing that. All right, so now let's make notes with that. So note that the objects of a finite set can be counted. All right, so let's go to infinite set. So we go to 2. All right, you go to 2 infinite sets. So let's write something down. Infinite set. Let me do this so that you see. All right, so let's do infinite sets. Infinite set. A set whose last member cannot be found is an infinite set. Full stop. For example, let's look at the example of infinite set. Okay. Let's look at example of infinite sets. I know you have all the notes there, but just that we want to glance through and then rejoin what we have to do. All right. Okay. So example. For example, we have, let's say, set of A. Let's say set A. Set of A. How do you write sets? So we bring this. Let's say set Q. Let's use set Q because we've used A before. So let's use set Q. 1, 2, 3, 4, 5, 6. Alright, the dot dot means that it continues. Alright, okay. So this is a positive integer which has a very continuation. We cannot, we can't get its last member. We can't count it and see the number of sets we have inside. Alright, so if you count 1, 2, 3, 4, 5, 6, there are it continues, so we don't know. So we say that it's infinite set. So this is let's write something. So set Q is the set of positive integers. So it's known as infinite set. Full stop. The 3 dots means the set continues indefinitely. Full stop. Note that all the objects of an infinite set cannot be counted as it continues indefinitely. For example, the set of all integers is an infinite set. Full stop. Alright, so I know it's clear, right? I know it's clear, very clear. Okay, so we cannot count infinite sets. It's to infinity. Alright, so there's no any explanation with this. Let's come to the third one, which is what we call unit set. Unit is what we call unit set. Okay, third unit set. So what is a unit set? What is a unit set? Now let's go. A unit set is a set which has only one member. Full stop. So a set with only one member is called a unit set. All right. So let's see example. Let's see example. So let's see example. Units. Unit means one. Unit set. All right. So unit set. We do our editing small and then. All right. So unit set. We says that unit set. It's a set that has only one member, right? So it's a set with a set with only one member is called, all right, it's called a unit set. It's a unit set. So come on, a unit set. All right. So example. Let's make an example. So for example, okay, so A, do I have to use A? Okay, let's use A, or let's use P equals, set P equals unit 5. That's only one member, right? We can also say that set A, which is 0, also has one member. Its member is 0. Okay, so 0. Okay, so 0 is only one member in that set. All right. Okay. So here we go. Let's look at a null set. Okay, a null set. You're looking at types of sets. All right. We are looking at types of sets, and then we know of finite sets, infinite set. Finite set has, we can count its members and know the number of members inside. Finite set, infinite set, we can't. Okay, so example is that we have positive integers. We cannot, we don't know, end of a positive integers. So we come to unit set, and unit sets means that it has only one member, and we have an examples down here. 0 is also, don't say that 0 is a 0, it means it's empty set. No, 0 is a member. All right. Okay, it's a number, so it's a member of a set. All right, so what do we do again? Let's look at null set. All right, so let's look at null sets. You're looking at null sets. All right. Oh, I should give space. All right, null set. Okay, so let's write something down. Null set. Okay. Null set or empty set null set is a set which has no member or element. Full stop. A null set is denoted by symbol. So this means empty set. Okay, this is how we write empty set. And also we do this we write an empty set as this, the way we write the set. Okay, so anytime that we see in our examination, in our exams questions, when there is something like this, it is that the set is an empty set. Hope it's clear. Alright, so let's continue. It's an empty set. It doesn't belong to anything inside. So let's delete what is inside. Okay, so let's continue. It's empty set. Alright. So here we go. Let's look at subsets and member of subsets. Subsets and member of subsets. Subsets and member of subsets. If all the members of a set, let's say A, belongs to a set B, then the set A is a subset of the set B. Full stop. I hope it's clear, right? Okay, so now let's look at examples. So here we go. So let's look at examples. Here we go. A subset. We are looking at subsets, okay? So let's write it here. Subset. Okay, a subset. And that's what we're looking at. So we say that let's say that set should be A belongs to a set. Let's say a set B. Then we say that the set A is a subset of set B. Okay? Alright, so let's see example. Let's see example. So how do we write a subset? So that is we can write it this way. So this is how we write a subset. So of B. Okay, so we say that A is a subset of B. All is clear. Very simple and cheap. Or we can also rechange this, to that side. We can rechange this to the other side and says that B, let's write or, okay, or B is also like this, so the same as what we've written. Okay, so it says B is a subset of A. Alright, whether this or that, but we are going to maintain this one. The A is subset of B, so that there won't be any confusion. All right, I hope it's clear. Okay, so now let's do that. So the symbol this a subset is called a subset of is means a subset. Okay, so let's write something. The symbol, all right, the symbol that we use, right? Present symbol this or that or that. All right. Okay, so we say that the symbol this or that means a subset of, right? It means a subset of. Okay, it means subset of. So in order not for us to be confused, we are going to use the other one rather. We are going to use this one particular. We are going to use this one in everything that we do, okay? So that there won't be any confusion. Alright. Alright, so now let's write something to let's note something. So in order not to be confused about how to use the symbols, comma, it is advisable to stick to the use of one symbol. It is easier to use so we say that this means a subset of, right? Means the symbol means subsets of. Okay, for us not to be confused, about how to use the symbols, it's advisable to stick to the use of one symbol. Alright, so we are using this one, okay? So that is it. So let's see for let's set examples and then we see what to do. Alright, let's see examples and let's see what to do with subsets. Okay, with subsets. Okay, so for example, examples, let's set examples of examples. So let's say if set A has 2, 4, 6. Alright. And set B equals 2, 4, 6, 8, 10, 12. Then we say that then A is, then you can say that, then we can say that A is a subset, right? It's a subset of B. A is a subset of B. I hope it's clear. Because the elements or members in A belongs to B. So A is coming from B. That is the meaning. Alright, so let's take that as the meaning. Okay. Now let's note this. Okay. Let's note this. Let's note this. Let's note this. I hope it's clear. So every element in B, in A belongs to B. So it means that B is coming from, B members are from A. Sorry. Then it means that A numbers are from B. So we select A members from B. Okay. So it means that A belongs to B. So simple. So cheap. Alright. Okay. So now let's look at something, and then I want us to finish on this type of set. Then we move on to okay, so let's set this example. Now we know we can set a lot of examples, but let's look at this. This is very important. Alright, so let's say if C alright, if set C has 0 and 1, if set C has 0 and 1, what do we have in set C? Okay, so let's see. If set C has 0 and 1, its members are 0 and 1. Then we can say that C has a subset of 4, right? Okay. Why are we saying that C has a subset of 4? Let us try to expand this. Alright, if C has a member of 0 and 1, okay, not only this, okay, but remember that this is also this is the same as this, right? So set B is the same as set C, set A is the same as set C. They all belong, they all have members in it, okay, but let's use the set C to do what we want to do, okay, to know a subset of C. Alright, so let us expand the C. So if we have something like this, then it means that set C has itself, is a subset of itself, which we can expand in this way. Alright, so C has a member of 0, right? It's true, right? C also has a member of 1. Is that correct? Alright. C also has a member of an empty set. Okay? And C also has and set C also has itself, which is 0, 1. So we can say that it has 4 subsets. So this set makes set C. So simple and cheap, okay? So we just take it 1. Set C has 1 member, which is 0. Set C has a member, which is 1. Set C has an empty set as well, because every set that belong that mem okay, so that is it. So let's note something down. Is it what we mean? Okay, so remember that C, we've expanded C, that, all right, C has a member of 0, has a member of 1, has an empty set, okay, and it has itself. All right, so it says that C. So let's write something down before we note something. All right, so it says that then we can say that C is a subset of 4. All right, C is a subset of 4. It's a subset of 4. So let's down something. Okay, okay. So we note down. Note that the null set is a subset of any set, and we allow any set to be a subset of itself. Full stop. Okay, that is it. So we note that, so what we note that any null set so we note that the null set is a subset of any set, and we allow any set to be a subset of itself. That's what we've done. All right, so a subset of itself, of C itself, is a 1 member, has 0 as another member, has 1 another member, and then an empty set. So whatever we write down, what we say is that list the subset of of the set, then we can do that. So let's take an example of this. Let's take another example and see if we do understand them. So let's write this. So let's look at this. Okay, let's look at this set. 1 4 6. We can say that set 146 could be is the same subset of and the same, let's copy the subset so that it will be very simple. It's the same subset of itself. Okay, so a subset of itself, which is 1 4 6. And we know that it also has what? An empty set as well. So simple and cheap. Okay, so here we go. Now let's try to bring a very interesting formula here. Let's try to code a formula for this. Okay, so let's write something. Let's write something. Okay. So we write in general, comma, if a set has n members, then the number of subsets the set has is equal to 2 raised to the power n. Alright. Okay, so 2 raised to the power n. Alright, so this is how we write it. 2 to the power n. So we are trying to generate a formula. Alright, so we say that in general, if a set has any members, then the member of subsets, we say that in general, if a set has n members, then the number of subsets the set has is equal to 2 raised to the power n. Okay, so let's set an example, right? Let's look at the example of what we are saying. Okay, so we do example. Example is let's write, for example, take too much time. Okay, for example, so let's do this. So we say that A, set A, let's say A, B, C. Alright. So how many members does it have? It has 3 members, right? It has 3 members. So if it has 3 members, how do we expand this? So let's say this has 3, 3 members, right? This has 3 members. Okay, so it has 3 members. So how do we expand this? As we know, you know that we will get empty set here. Then what else are you going to get? Itself is another one. It has A, it has B, it has C, and it will also have AB. It will also have BC. It will also has AC, right? So you know it will be 8, right? So let's see what how we can expand this. Okay, all right. Okay, so let's expand it. So set A, which equal to A comma B comma C, we can say that its members, we are listing it. It has an empty set, right? Like the rules that we said, we are looking at subsets. So any subset, you know, has an empty, has a null set inside, and any set is a subset of itself, right? So we have one element which is an empty set, a null set. We will also have A is also a member. We can also mention of B being a member. What of C? C is also a member, right? C. So how many members do we have now? We have 1, 2, 3, 4. Okay. Then we can say that A and B also belongs to that. What about A and C? They also belongs to that, right? Okay. What about B and C? It also has it, right? It's also a member. And also we have itself, which is A, B, C. So you know how many do we have? Can we count them? Let me separate it so that it becomes very beautiful. Okay. So we can count them, right? Okay, let's do it. Okay, let's count them. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8, right? So it's a subset of 8. Okay, it's a subset of 8. It's a subset of 8, right? It has 3 members, right? Okay. So how do we use this 2 raised to the power n in this case? Okay, so far as we have 3 members, we could also do it this way to make it very simple without expanding it. Okay, so we can say that 2, we read that in general, if a set has n members, then the number of subsets the set has is equal to 2 raised to the power n. Alright, so we are proving it. So now we have 8 members. So let's write 8 subsets. All right, 8 subsets. Okay, so we are here to prove with our formula what we have. So A, we are not expanding it, but we are saying that A, which is that set, has, all right, so let's do it this way. So we say A is a set of A comma B comma C comma B comma C, which has 3 members. All right, its members is 3. So now we know the members of A, which is 3. Then we say that 2 raised to the power n could be the subset. So 2 raised to the power n. Where is my pen? Oh. So 2 raised to the power n alright. Okay, so we have 2 raised to the power n. We give us what? To the 2 raised to the power n gives us what? So here we go. So 2 raised to the power n will give us 2 in the power of 3, which equal to what? 2 in the power of 3 is what? Is 8, right? Always clear. Okay, let me do this and then you understand. It's very simple. Okay, so as we can prove, we're able to know that set A has A, B, C, okay, which has 3 members. So we says that let n be the number of members in the set. So we says that n equals 3, which 2 raised to the power n is a subset of the set. All right, so we do 2 raised to the power n, which is 2 raised to the power the 3, the members in it. So 2 times 2 times 2, which gives us 8. So this proves our expansion here. It makes it very, very clear. Okay, so we have us in the exams they said expand this, write the subsets of set A equals A, B, C. You can write it, right? But when they didn't say state this or what is the subset of this set, there's no need for you to expand it, especially when it's in section A. You just have your 2 raised to the power members, count the members, then you expand it, then you write the final answer. All right, so let's do universal set. All right, okay, so we are on universal set. We are on universal set. Okay, universal set. So we are 7. So universal set it is the set of all the objects under discussion. Full stop. When a particular set is defined, we consider it as a subset of a larger set which is referred to as universe set. Full stop. For example, if the set of triangles is under discussion, then the universal set is taken to be the set of all polygons. Full stop. The universal set is represented by a rectangle in a Venn diagram. So we are going to look at Venn diagram. All right. Full stop. So that's universal set. You see, don't worry about the reading. Don't worry about the words. Universal sets. Every set belongs to universal sets. All the members of sets belongs to universal sets. Okay. So the symbol of universal sets. Let's look at the symbol of universal sets. Let's look at the symbol of universal sets. Symbol of universal sets. So simple. It looks like U. Okay. Universal set symbol. Universal set symbol. So let's look at symbol for universal sets. Is looks like, okay, so symbol symbol of universal set. So we can write it this way. It's like U. It's like U. Just write U, the letter U. Okay, U. Okay, so this is a symbol of universal set. It looks like U, right? Or alright, something like that. Okay, so anytime you see a symbol like this or symbol like this, normally we use this to write as universal set. So that's it. That's how it is. Okay, that's how it is. Okay, so now we know how. Alright, so we need to end here and continue on next time. Okay, and continue on next time. Okay, so next time we'll look at equal sets, equivalent sets. That's the only two left for us to look at. So in our next video we are going to do that. Okay, we are going to look at that, and then we come and look at Venn diagrams. Then we solve, one or two equations more. We solve a lot. We solve more, samples and the way we're doing. Alright. Okay, I have corrections to make here. I think you got it correct. Okay, I know you get it correct, but um but my machine is giving me a lot of um you know problems, but I know you'll get it correct, so don't worry about that. So we are going to end it here. Next time we will look at what we have to look at, and then we always encourage you, as I always say to you, do not forget to donate to support us, because your donation helps a lot, and therefore count to see you donating to support us. 0245 and also remember to tell a friend to join us. Okay, so the next time we continue, we are going to look at the other two left. We have equal sets, we have equivalent sets, then we will look at Venn diagram, then we come to set operations, we look at the union, then from there we will dispatch. Okay, elective maths will take itself to three three sets. Okay, then we come to see complement of a set, union of a set, intersection of a set, and a lot. So when we are done, we go to past questions. We solve everything. All right. So we're ending it here. Don't forget to donate. Okay, 0245 027888780. And again, remember that we have other classes that's ongoing, that you can enjoy them. All right. Okay, so bye bye, have a nice day, nice to meet you.